Today, we discuss the question 18 of Past Year Ulangan paper in 2022, question 18. So the first one, state 3 ways to increase the capacitance of an isolated parallel plate capacitor. B, parallel plate capacitor, resistor, and EMF are connected in series. Derive an expression for the charge in the capacitor as a function of charging time. Both these questions are actually in the syllabus. So let us go through. So from the formula of the capacitance that we have epsilon A over D. So there are three variables in the formula. So you can just state three ways based on the variables. First one is the epsilon R, okay, where we can insert a dielectric in between the plates of capacitor. And then we can increase the area of the plate. And the third one is to reduce the distance between the plates of the capacitor. So this should be no problem for you. So the next one is about the derivation of the charge in the capacitor. So it is already in the syllabus and you need to do some practice to really master the derivations. So basically you need to remember the circuit that we have the EMF, the resistor and the capacitor. So just to remind you that you should always use the symbol given in the questions. So the special symbol is the EMF where the E, okay, we are used the E here. So just do whatever you have learned before that we have to apply the total EMF is equal to the voltage across resistor VR plus VC. And then roughly go through the derivations. So first we have the VR is equal to IR and VC maintained since we want to get the potential difference across the capacitor first. And then we're going to substitute the I as C dVdt as what we have learned before. And then we shall perform the integrations. So, and then you rearrange all the formula given, and in the end, you can get the voltage across the capacitor is the EMF multiply 1 minus e to the power of negative t over RC. And then we need to find out the charge, just apply the formula of Q equal to CV. So for this kind of questions, you just need to do more practice and make sure you can score all the marks given in the exam. So we move on to question C. An air-filled parallel plate capacitor is separated by a distance of 3 mm and the plate has an area of 20 centimeters squared. Calculate the capacitance of the capacitor. So quite straightforward. We just use the formula epsilon naught A over D. So all the information are given, just put them in. So the answer for this one should be around 5.9 times 10 to the power negative 12 farad. And for the second question, we have a mica of dielectric constant 7 is inserted between the plates. Calculate the new capacitance of the capacitor. So we have the formula of C equal to epsilon R multiply the A capacitor, okay, the capacitance of A capacitor. So the answer should be 4.13 times 10 to the power negative 11 farad. And then the last question, if the capacitor in C2 is connected to an EMF of 12 volts, calculate the energy stored in the capacitor. Also straightforward that we have the formula of half CV squared. Just put all the values given and the energy is 2.97 times 10 to the power negative 9 joule. So that's all for question 18. Thank you.